Hey everyone, in this video I'd like to do an example where we classify a quadric surface from its formula, but maybe the formula is not so clear to tell which one it is. So remember that the standard equation of a quadric surface, or the standard formula, is that we have a formula that looks like this: ax squared plus by squared plus cz squared plus dx plus ey plus fz plus g is equal to 0. And the idea here is that to make this a quadric surface is that by the way, all of these capital letters, A, B, C, D, E, F, G, these are all numbers, right? But one of A, B, or C is not 0, right? So there's at least one term that has a non-zero coefficient for these squared terms, right? Well, there's a lot of different ways to classify these. So what I want to do though is, given this, right, we have examples of the shapes of these surfaces when we can really look at these in a slightly different form. So I'm just going to stop talking and write this down. So let's say we have an example that looks like this. Let's say we have 4x squared plus y squared minus z squared minus 24x minus 8y minus 4z plus 55 equals 0. And I want to know what quadric surface is this. So can we classify the quadric surface? All right, so to do this, what we have to do is try to get it into a form where we have completed the squares, right? So what I'm going to do is rearrange this entire thing. So completing the square is the main tool here. It's the main tool. So I'm going to write this in a couple steps. So first of all, I'm going to group together the x's. So 4x squared minus 24x. This is all 1, right? And then plus y squared minus 8y minus z squared minus 4z. And then I'm going to move the 55 to the other side, just because it's going to be easier for us to work with. All right, and now one more thing I'm going to do is kind of space these out. And I'm going to factor out leading coefficients, because to complete the square, you always need a leading coefficient of 1. So this first one, I'm going to write 4. This is right, but 4x squared minus, and then factor out a 4 from here, right? So 4, that'll leave this as 6x, and then I'm going to leave a blank, so plus blank, because that's where I'm going to complete the square, okay? And then the next one is fine. There's no problem, but I'm going to put parentheses anyway. So y squared minus 8y plus blank. And then this one, we need to factor out this minus sign. So here I'm going to have minus z squared plus 4z plus blank. And then obviously we've got the gap there. We need minus 55 over here. And now we just have to be really careful about completing the square, right? So how does completing the square work? Well, the first step is to, once you've got everything factored out like this, that's the first step. The next step is to then look at this middle term, right? And then what do you add? You add half of this squared. So half of negative 6 is negative 3, squared is 9. So I'm adding 9, right? But actually I'm adding 4 times 9. So over here I have to do the same thing, right? 4 times 9. So adding 4 times 9. So this 4 has to be involved, right? You can't just ignore it. I need to add 9 on the inside. That means it's 4 times 9 that I'm adding to the total. If you add that total to the left-hand side, you have to balance the equation, add it to the right-hand side. So we go to the next one. On this one, we're adding negative 4 squared. That's 16. Here, the coefficient is 1. So we're truly adding 16, right? And then on this side, we're adding 2 squared is 4. But when we add 4, we're actually subtracting it, right? There's a minus sign here. So minus 4. It's got to get balanced out on this side. Minus 4. All right? Now, at this step, we have a couple things to do. First of all, we need to just factor this, right? So we have 4 times, and the reason that this is called completing the square is because this will become a perfect square. And what does it become? Well, it's x minus 3. X plus whatever that middle term was, half of the middle term. So x minus 3, quantity squared, plus this one's going to be just y minus 4, quantity squared, right? And then this one's going to be minus z plus 2, quantity squared. And then on the right hand side, we need to figure out what this number is, right? So I'm going to work it out in steps here, but negative 55, this is plus 36 plus 16 minus 4. And so 36 plus 15 is 52, which means this adding this in is a negative 3, so this whole thing is negative 7. All right, I hope. But it should be negative 7, I believe. So yeah, 52 minus 55 is negative 3, minus 4 is negative 7. All right, so at this point, we're almost there, right? We've got everything arranged, and as far as the book is concerned, the way that the book does this, what we should do now is divide through by this coefficient, by this thing, to get this to be a 1. So if we do that, if we divide through by this, or I'm going to do this 2 ways actually, so we're going to put a star here because we're going to come back to this equation. To get this to look like the book's equation, this becomes negative 4 over 7 times x minus 3 quantity squared minus 1 over 7 y minus 4 quantity squared plus 1 over 7 z plus 2 quantity squared equals 1. All right? And so based on the way the book does this, this has a minus sign, a plus sign. 2 minuses and a plus. That's going to give you 2 sheets, right? This is a hyperboloid. So if you get it in their standard form with a plus 1 on this side, and this is all just squares, then you count the minus sign. So hyperboloid of 2 sheets. So that's the way the book does it. The way that I prefer to do it is just to move this over to the other side and get it so that these are all positive. All these terms are positive. So another way is to write this as just 4 times x minus 3 squared plus y minus 4 quantity squared equals, move this over, z plus 2 quantity squared minus 7. All right, and so we had a rule in the previous lecture where we did the sketching of the quadric surfaces, that if this is positive, you have 1 sheet. If it's negative, you have 2 sheets. So the conclusion is the same, right? It's just a matter of how you want to look at this. And based on the way this looks, right, we've got a 4 and a 1 here. This is going to be an elliptic. It's an elliptic hyperboloid of 2 sheets. And the center point of this thing, so it obviously has a gap with its 2 sheets. It opens in the z direction, right? So it looks something like this, right? And this point in the center here, the center of everything that's going on, this point is given by these, right? So it's given by 3, 4, negative 2. This is just the shift. This is the shift of the shape, right? So that point right there is given by, just as you would with a line or anything else, the shift goes opposite, right, of what's happening here. So 3, 4, negative 2. All right, these are all pretty much the same applications of completing the square and then carefully getting them in a form that you can identify. If you go by the book, you use this one. If you kind of just have a different way to remember it, you can use this one. As long as you properly identify the surface, you can use either method.